What we're going to use is we're going to use a little licorice. We've actually rolled it down so it's about 1.5 centimeters long. It's actually meant to represent the circumflex artery. Now, one of the things that happens is what we were looking at is if we look at the femur, we have our circumflex artery and it fits straight into the acetabulum here. Now, one of the things that people don't pay attention to is going to the straight skeletal model. The hip actually only has a certain amount of movement before it starts hitting the joint here. One of the things you'll see with dancers is they'll rotate their leg out as they come out. So when they actually do the splits, their feet are actually pointing up instead of to the side. What you'll notice is if your foot is to the side like this, you have a lot of interference with bones on the neck and on the greater trochanter. Now when we look at a kick, like the side kick, coming this way, a high kick, we can see how it's going to, the joint will actually end up interacting with itself. Now, what we're going to use is we're going to use these things independently so I can add something. The truth is the acetabulum does have some cartilage where the femoral head fits in, and the artery that feeds the head of the femur is actually coming from on top here. So it comes from up here, and we actually want it to turn this way, and goes up this way. Now, what ends up happening is if we look at how the hip is arranged, this should come in like this. As we lift, what we end up seeing is damage that would end up being caused by the hip being adducted too far. Well, this is just a basic modeling. It is using the artery at the right size. It is looking at damage that could be caused on the artery based on bone, hitting against bone. And while more studies are needed, we can actually see that, yes, this will actually interfere with the circumflex artery and the smaller arteries of the femoral head